Okay, so to start learning about radioactivity, first we just need to know what it is. Okay, so radioactivity, it's the emission of ionizing radiation from nuclear decay. Now, does that just sound like a whole bunch of vocab words kind of put together? Yes. Yeah, so let's break that apart. What does that actually mean? What is emission? What does that mean? If like you're emitting something, what does emission mean? Okay, like giving off. Okay. Ionizing radiation. What word do you know in ionizing? Good. Ions. And what are ions? Okay. Plus or negative charges. Okay. And then what's radiation? Like when the sun like radiates, what's it giving off? Heat, and heat is a form of energy. Okay. And then it's from nuclear decay. What does decay mean? To break down, right? So when the nucleus breaks down, it's going to give off energy, okay, and some ionizing particles. So when we look at radiation, there's 3 different types of radioactive decay we look at. Okay? So today we're going to look at alpha, beta, gamma, okay? And we'll learn like what those particles or rays look like. And then we'll learn how to write equations for them. If we look at them in this order, alpha, then beta, then gamma, this goes from least amount of energy to most amount of energy. Okay. So our first type of decay is alpha decay. Okay. So alpha decay occurs when an unstable nucleus changes into another element. And while that happens, it shoots out this particle that's composed of 2 protons and 2 neutrons. So what you need to write down is what I'm going to write down. So when alpha decay, it loses something called an alpha particle. And we write it like this. All right, so that top left number, this is that mass number. Bottom left is just the number of protons. And then this, we call it an alpha particle. So this is the Greek letter for alpha. I kind of think it looks like a fat Jesus fish. Okay. Can you see it? Are you seeing it? Okay. Also, what other particle or element do you know that has a mass of 4 and has 2 protons? What has 2 protons? Helium. Does it also have a mass of 4? Okay. So some people will also write an alpha particle like this. So a mass of 4, 2 protons in helium. Now the key is here, this is not a helium atom, it's only a helium nucleus. Okay, so you don't lose the whole atom, you're just losing the protons and the neutrons. Okay. So either of these are appropriate ways to represent an alpha particle. I tend to go for the alpha one. Okay. It's super common to see helium right now. All right, so then take a look at our picture. So here we have this parent nucleus. Okay. When it undergoes alpha decay, it loses this alpha particle, or 2 protons, 2 neutrons. So then it changes into a new element. We would call this the daughter nucleus. All right, next we have beta decay. During beta decay, again, an unstable nucleus will change into a different element. While this happens, a neutron ends up decaying into a proton. And then the nucleus emits what we call a little beta particle. So then the way we write a beta particle, it has a mass of 1. It doesn't have a proton, it has a negative charge. And then the Greek symbol for beta, it's like a capital B with like a little tail at the end. Or what other particle do you know of that doesn't have a mass and has a negative charge? Which subatomic particle has a negative charge?
An electron.
Good. Or an electron, right? So it basically is emitting an electron. Okay. So again, you might see people write the symbol like 0, -1, and B for beta. Or you might see 0, -1, and a lowercase e because it's essentially an electron. Okay. Again, either of those are fine. You see it written both ways. All right, and then our third type of radioactive decay is just gamma decay. This happens when nuclei move from a high energy state to a low energy state. When this happens, they just release energy, or like photons. Do we know what a photon is? It's just light. Okay, so like little packets of light. Okay, so this one doesn't give off a particle. It just gives off light energy. And by light, I mean electromagnetic energy. So not like this small little range of visible light. Okay, in gamma decay, it gives off energy in the gamma range. Okay, or high energy. Okay. So no mass, no charge. Okay, it is just energy. And then the symbol for gamma, it's kind of like a Y with like a loop at the base.